Let's take a look at this related rates problem. Related rates is my favorite topic in all of calculus, so love this question. In this one, we have a 10-foot ladder that's leaning against a wall, and you're told that the ladder is being pulled away from the wall at a rate of 0.4 feet per second. Okay, now let's talk about how this is labeled here. Anything that varies in the problem, even if you know its distance at the point of interest, if it varies, it must have a variable, which is why I've labeled the horizontal x, even though the point of interest is when it's 6 feet from the wall. It's not always going to be 6 feet from the wall. Anything that varies must have a variable. So I labeled the horizontal distance x, and at the point of interest, x is 6 feet. Now, the ladder is not a variable because that 10-foot ladder is not going to suddenly change length just because you're pulling it away from the wall. So this horizontal, or I should say the hypotenuse here that's represented by the ladder's length, it's not going to change at all, doesn't need a variable. The height up the wall certainly needed a variable. I wanted to go ahead and, since it's a height, it's a y position, I label it y. Now, I had to solve for y, even though I noticed this was a multiple of a 3, 4, 5 triangle. It's a 6, 8, 10 triangle. But just to show, in general, you would need to solve for the other dimensions. So you'd say 6 squared plus y squared is 10 squared. Thus, y squared is going to be 100 minus 36, or 64. And then we know, since y is an upward distance, it has to be positive. Positive square root of 64 is 8. So I can say the distance up the wall at the point of interest is 8 feet. Now, I'm trying to find out how fast that ladder is moving down the wall if it's being pulled away from the wall at a rate of 4 feet per second. It's important that you label all of your derivatives in this problem. Now notice, this is going to be a rate of change of how fast the horizontal is changing. Thus, this 0.4 feet per second is dx dt. And I know it's a positive 0.4 feet per second because the length of x is increasing here. If the problem had said it's pushing it towards the wall at a rate of 0.4 feet per second, it would have been a negative 0.4 because x would have been decreasing. But in this case, x is increasing, thus dx dt is positive. Now, I go back and I use my Pythagorean theorem, x squared plus y squared is equal to 10 squared. And I know that that's going to, if I take the derivative of that expression, it's going to involve every derivative I need, the one that I know and the one I need to find out. So when I take the derivative with respect to time, the derivative of the horizontal, it's going to be 2 times x times the derivative of the inside. Derivative of x with respect to t is dx dt. Then I take the derivative of the y squared. I would get 2 times y times to the first power times the derivative of what's inside, which with respect to time is dy dt. So you need to think about all of these as a chain rule. I think of them as groups to those powers. So you say the 2 came down in front times the group y to the first times the derivative of the inside. That's where that dy dt came from. Now, the derivative of any constant, 0. So 10 doesn't change with respect to time. Its derivative is 0. Now, at that point, what I did is I just said, well, I could divide by 2 on each side, and those 2's there are useless. They just cancel right out. Now, after dividing by 2 on each side, I plug in what I know. X at the point of interest, it's 6. dx dt, we're told it's increasing at a rate of 0.4. So 6 times 0.4 plus the y term. We know y at the point of interest was 8, and we're asked to find out what dy dt is. So it's a nice thing in an equation when you know everything except the term you're trying to find out. This gives us an expression to solve for dy dt. So I went ahead and I moved the 6 times 0.4 to the right-hand side. When I do that, it becomes a negative 2.4. Then I divided by 8. Negative 2.4 divided by 8 is negative 0.3. Now this is change in position over change in time. Position in this problem was measured in feet. Time was measured in seconds. So I would say dy dt is a negative 0.3 feet per second. Now that's how I would want the answer on a test, just like that. But please be very careful with the way that the question is worded here on MyLab. It specifically says when the foot of the ladder is 6 feet from the wall, the top of the ladder is sliding down the wall at a rate. So I would never say it slides down at a negative 0.3. That would imply that maybe it's going up. So down already incorporates the negative. So the negative is incorporated by saying it's going down. So you would just say, well, it's sliding down the wall at 0.3 feet per second. And this is the answer that MyLab is looking for there. All right, good question. Love this section. Hopefully this helped you out with this one.